Hello and welcome to Soft Papers channel. My name is Mr. Godfrey. In this video I'm solving a Cambridge IGCSE chemist topical paper on organic chemistry. This is a 2019 June exam series. Topical questions is the way to do good revision, and that's why I prepared these questions to help you in your revision as you await or as you prepare for your next Cambridge examinations happening in June and beyond. And therefore, I need you to read your notes and your textbook on organic chemistry, and then when the content is fresh, when you have revised the topic, come and then let's do these questions together. Chemistry is an easy subject when you go topic wise, and this gives you good preparation to be ready for your exam. Before we begin, if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will always be notified every time I upload a new video. Let's get started solving this question. Of course, this question, every question has got this kind of writing here. This tells you this is question that was set on variant 3.1. These are structural questions on May-June. MJ means May-June 2019, and that was question number 5. So I'd like you to be able to check that if you need to refer this question in your past paper or in your marking scheme. That should be what you're looking forward to. So let's talk about the first question here. Coal gas is made by heating coal in absence of air. The list shows the main gases present in coal gas. We have carbon monoxide, we have carbon dioxide, we have ethane, hydrogen, methane, and nitrogen. This is what we call the coal gas. All of these make what we call coal gas. Which one of these gases is an alkane? Which one of these gases is an alkane? And of course that should be methane. Methane is an alkane. Of course methane is this one. An alkane has got all single bonds formed between carbon and hydrogen. Ethane, which is the other organic gas, is an alkene, not an alkane. Is an alkene. The rest, hydrogen, nitrogen, carbon monoxide, and carbon dioxide, these are not organic gases. So the answer there is alkane. Answer there is methane. Draw the structure of molecules of ethane. Show all atoms. Show all atoms and all the bonds. Of course, ethane has got two carbon atoms. So you get your 2 carbon atoms and a double bond between them. And of course, it has got 4 hydrogen. Of course, ethane is written that. So you show all the carbon, all the atoms, and all the bonds. So that is ethane. So you show it. Part 3. Describe how aqueous bromine can be used to tell the difference between methane and ethane. Of course, with methane, we are showing the difference between methane and ethane. With methane, bromine remains orange. The aqueous bromine remains aqueous bromine remains orange, meaning no reaction has occurred. Then with ethane, bromine, the aqueous bromine changes colorless. Bromine becomes colorless. So it gets decoloralized. It becomes colorless because a reaction of because of this reaction. This is thin, okay, plus aqueous bromine, aqueous. So what you'll get is this compound here we call dibromoethane. This is hydrogen there, hydrogen, bromine, and hydrogen there. So this is dibromoethane, and this is colorless. This is colorless, and this one is brown. So the change color from brown to colorless tells us the reaction has occurred. Question number B. Ethane molecules react with each other to form polythene. What is the name given to this type of chemical reaction? This chemical reaction is called polymerization. Polymerization. Add these small molecules together to get a big molecule. The small molecules are called monomers. Part 2. Which one of the following words describe ethane, the small molecule, in this reaction? Draw a circle. The circle is this. Ethane is a monomer. Polythene is a non-biodegradable plastic. What is that? What is meant by the term non-biodegradable? This means it cannot be decomposed by organisms. Okay, cannot be decomposed. Cannot be decomposed by organisms. That's why we've got a lot of plastics all over the world that are buried, and that will remain in that state almost forever because they cannot be decomposed. Part 4. Describe one pollution problem caused by non-biodegradable plastics. One pollution. Of course, most of the plastic, when you throw them away, this will block drainage systems. Blocks drainage systems. Of course, we need our drainage systems to be clear. When they are blocked and it rains, then we get floods in our residential areas. That is one. And also another one, can give you a bonus, gets stuck in gullets when they are eaten by birds or animals. Gullets of birds or animals. So that makes it a pollutant, and when it gets stuck, the animal is likely to die. Part C. Ethanol, which is an alcohol. Ethanol can be made from ethane as one other reactant. Name the other reactant. The other reactant is usually steam. Of course, the other one is called steam. And of course, you know the reaction. Ethane plus steam, water in gaseous state. This will give us ethanol. Give us ethanol. This is an addition reaction. This is ethanol. Right, state the condition needed to make ethanol from methane. You need to have high temperature. You need to have high temperature. And the other condition is we need a catalyst for this reaction to proceed. It's great you're watching this video. Remember, you need to practice working out this question yourself. You may get this same paper I'm solving right now from this website here, softpapers.co.uk. The site I'm talking about is this one here. This is Soft Papers, and it's a very rich site with a lot of resources, as you can see. What we are dealing right now is Chemist 2019. I need you to go right there, and this is where you come. We are dealing with June. Of course, you'll find 2019 November. Topical questions structured and multiple choice. A few are solved for you to have an example. What we are dealing with is June. We are dealing with June structured question, which is organic chemistry. So I need you to get this paper. You need to click here. Get all solved papers in a zip folder. You'll come right here, and this is where you're going to get what we are working. You go to June, chemistry structured questions. You need to click this one to add to your cart. Ask your parents to help you with acquiring these papers. They are fairly charged, only in 9 pounds, and you can get as many as you as possible. All these other years also are very present, so do as much practice as you can. This will mean that you will find it easy when you're sitting for your exam in the next coming exam series. So don't fear to spend a little to sharpen yourself as you prepare for the exam. Great. So let's go to question number 2. Methane, ethane, and ethene are hydrocarbons. Hydrocarbons are compounds that have only carbon and hydrogen as the only atoms. Draw the structure of a molecule of ethane. Show all the atoms and all the bonds, right? So ethane has got 2 carbon atoms and a single bond in between, and it's bonded to, of course, ethane is this 6, so it's bonded to this number of hydrogen. So you have 6 hydrogen atoms. You give them right there, and 2 carbon atoms. So that is ethane. You've shown all the bonds and all the atoms. Part B, which one of these compounds belongs to the same homologous series as methane? Of course, homologous series is a group of compounds that have got similar reactions due to the same functional group. The same functional group. That's what we call homologous series. Draw a circle around the correct answer. Which one of these belongs to the same homologous group as methane? So these are alkenes and alkanes. Alkanes, not alkenes. And alkanes are one of the compounds is butane. This is a carboxylic acid. This is an alcohol, and this is an alkene. This is an alkene. Of course, the methane I've said is an alkene. This is an alkene. Propene is an alkene. This is an alcohol, and this is carboxylic acid homologous group. So this is the only alkane that we have there. So you cycle that. Part E. Ethene can be manufactured by cracking. Right, complete the sentence about cracking using words from the list. Crack is the process of breaking down. I'll go for large or larger alkane molecules, alkane molecules into smaller, I'll go for smaller, into smaller alkane and alkene. So that's how you complete this sentence. Okay. Molecules into smaller alkanes. State two conditions needed for cracking. 1, you need high temperature to have good enough energy to break the bonds, because cracking involves bond breaking, and you also require catalysts for this to happen speedily. Catalyst speed the rate of reactions. Remember that. You need a catalyst, and the catalyst used here is aluminium oxide catalyst. Right, part D. Part D. Polythene is made by polymerization of ethane. Which one of the structures represent part of ethane molecule? Tick one box. Let's take one box. Let's go here. Let's take one box. So we are told that polythene is made by polymerization of ethane. Which one of the structure represent part of the polythene molecule? Right. The box I need to tick this one. Of course, there's a double bond here, so this is not a polythene. When ethane participates in the bonding to produce polythene, this double bond is destroyed. So there are no double bonds in polythene. And of course, ethane is just a molecule of 2 carbon atoms. So as you can see here, you don't have this in ethane. Therefore, that is not right. This is not right because of the double bond, and this is not right because of the OH. This is not. This is an alcohol polymer. So the only correct structure for polythene is this one over here. Right, part E. Nylon is also a polymer. Nylon is also a polymer. Give one common use of nylon. Nylon is used for making clothes, ropes, and stuff. So making clothing, ropes, nets for fishing, or fishing lines. Or fishing lines. I hope you've gone fishing one time. You have used the fishing line of nylon. Right. Part of the structure of nylon is shown. Okay. Nylon bonding with nitrogen there. How many different types of atoms are shown in this structure? I can see nitrogen, hydrogen, carbon, and oxygen. There are only 4 different types of carbon atoms I can see right there. Part F. The structure of a monomer used to make a polymer is shown. Okay. We have this structure here used to make a polymer. Okay. This is an ether. Okay, don't worry about that. What structure or feature of this molecule shows that it is unsaturated? Of course, carbon double bond, carbon double bond. That is what we call saturation, double bond. So as long as it has got carbon double bond, then it is unsaturated. A saturated compound has only single bond, does not have double bond. When it has a double bond, that is unsaturated compound. Describe a test to show that this compound is unsaturated. We use aqueous bromine. You can also call it bromine water. Bromine water is brown. in color, and when it is added through the double bond, it turns colorless. Colorless. So it turns from brown to bromine water, turns from brown to colorless, and that is when we know the compound has got the compound is unsaturated, has got some double bonds. Very well. Question number 3. Question number 3 was set from variant 3.3. This was number 5. The structure of compound S is shown. The structure of compound S, it has got a ring with 6 carbon atoms. Of course, this is an acid because it has got the acidic functional group right there, and it has also got an alcohol functional group right there. So notice that. Draw a circle around the carboxylic functional group in this structure. Oh, the functional group of carboxylic acid is that. Remember, functional group of carboxylic acid is this. So you look for a double bond bonded to carbon and oxygen, and that carbon is bonded to an OH. That is the functional group. How many different types of atoms are present in this structure? I can only see carbon, oxygen, and hydrogen, so 3. Right. Part B. The melting point of S is 159 degrees Celsius. The boiling point of S is 200 degrees Celsius. What is the physical state of S at 100 degrees Celsius? If it melts at 150 degrees Celsius, then at 100, then it is a solid. Solid at 100 degrees Celsius. Explanation is that 100 degrees Celsius is below the melting point. Of S. So at 100 it should be a solid. Part 2. Which one of these statements about an impure sample of compound S is correct? Take 1 point. Which one is correct? Impure. What does impurity do to the melting point? What does impurity do to the boiling point? Impurity lowers the melting point, and impurity in a sample raises the boiling point. And therefore, melting point of S is 159 degrees, and boiling point is above 200 degrees Celsius. Okay. Impurity will lower the melting point and raise the boiling point. So it has not lowered the boiling point. It has not lowered the melting point, although it has raised the boiling point. So that is not correct. The melting point of impure S is below 159. That is correct. And the boiling point is at 200. It has not changed the boiling point, though it has lowered the melting point, which is correct. So the whole thing is not right. The whole statement. The melting point of S is this. The melting point has not changed, and therefore that is not correct. The melting point of impure S is below 150. That is correct. And the boiling point is above 200. So the right answer is that. So we take that. So what I've said that impurities lower the melting point and rise the boiling point. Okay, so that is the answer. Number 6, part C, sorry. Part C. Aqueous ethanoic acid as a chemical property which are typical of acids. Aqueous ethanoic acid. Describe 2 chemical properties of aqueous ethanoic acid typical of acids. What do acids do? Acids will react with a base to form salt and water. So Likewise, ethanoic acid reacts with sodium hydroxide, which is a base, to form salt and water only. That is the typical reaction of acids. Acids will also react with calcium carbonate to form salt, carbon dioxide, and water. Those are typical reaction of acids. Of course, you can go for this reaction here. Sodium hydroxide plus ethanoic acid. Ethanoic acid is this one here. So it will react to form a salt called sodium ethanoate plus water only. And same as here, calcium carbonate react with the ethanoic acid, will form calcium ethanoate, which is a salt. Of course, is times 2 because calcium has got oxidation state of 2 or valency of 2, plus carbon dioxide, which is a gas, plus water. Part D. Ethanol can be converted into ethane by passing ethanol vapor at a catalyst of aluminum oxide. Right. Identify compound X. Of course, you can see here. You can see this one has got 5 hydrogen, or I can just write this one where carbon is 2, hydrogen here is 6, and oxygen is 1. This one has got 2 carbon atoms. We are trying to find what is X, and hydrogen here is 4. So the only difference is 2 hydrogen here and 1 oxygen. So this is 2 hydrogen and 1 oxygen, and therefore this makes it water. Therefore compound X is water. Explain why a catalyst is used. Without a station, catalysts speed up reactions by offering a route of low activation energy. At the end of the reaction, the catalysts are not changed. Catalysts do not change the activation energy. They only have an alternative route with less activation energy. Draw the structure of a molecule of ethanol. Show all atoms and all bonds. Of course, ethanol has got ethanol has got 2 carbon atoms, as the word suggests. Of course, since it's an acid, since it's an alcohol, give it OH. Hydrogen there, hydrogen there, hydrogen there, hydrogen there, and hydrogen there. But you're told to show all the bonds. You have not shown about the bond between oxygen and hydrogen, so we should show that. So that is all the bonds are now displayed. Part E. Ethane can be polymerized. State the name of the polymer formed when ethane. Name of polymer when ethane is polymerized. We call it polythene. Polythene. You can write without brackets. Doesn't matter. You can just call it polythene. All right. Just that. Pterylene is also a polymer. State one use of pterylene. Pterylene is an ester, and therefore one use of pterylene is for making clothes. Makes shirts and dresses and stuff. Makes clothing. That's one use of pterylene. Very well. I would also like to welcome you to my online tuition classes. I also do online tuition classes at this site, SP Academy, Soft Papers Academy .co.uk. The site I'm talking about is this one here, Soft Papers Academy. This is the site I'm talking about. You can find also other subjects: ICT, mathematics, physics, biology, and chemistry. I'm doing chemistry, and I'd like you to come here and look at a step-by-step guide for students' dashboard functionalities. You can also watch this video to get familiar with the online live classes. And to do that, to book a lesson, you need to log in or to sign up or register. So come here and register. Of course, you select the student or a tutor if you're a tutor. Give the correct email. An email will be sent to your inbox for you to activate your account. And of course, when your account is active, you need to come here and then you log in. And therefore, when you logged in, you go to your dashboard, and therefore you can choose, you can find a tutor, and you can ask for my help. If you need my help in chemistry, I'll be glad to help. So hopefully I'll be seeing you on my tuition classes at spacademy.co.uk. Let's continue with this paper. Question number 4. The structures. Of course, question number 4 was on variant 4.1, and this was number 5. The structures of 5 alkenes, A, B, C, D, and E as shown. Of course, A, B, C, or they are all alkenes of different names, but the functional group for all of them is alkene. What is the general formula of alkene? Of course, general formula of alkene is CnH2n, right? Like ethane. Ethane is CH4, right? This is ethane. So if you have to write if n is 2, then 2n will be 2 times 2, which will be 4. Therefore, the general formula for alkene is CnH2n, right there. What is the formula? What is the molecular formula of alkene D? D is this one. To get the molecular formula, you count the number of atoms present. There are only 2 types of atoms, carbon and hydrogen. So how many carbon can you see? 1, 2, 3, 4, 5. So 5 carbon atoms. How many hydrogen do you have? We have 1, 2, 3, 5, 7, 10. So the molecular formula of alkene D is C5H10. C5H10. Let me write it nicely. C5H10. Very well. C. Predict which alkene A, B, C, D, or E has the highest boiling point. Explain your answer. Highest boiling point. Get back to the alkenes. The alkene that has got the highest boiling point is the largest alkene of them all, because it has got strong bonds between molecules, what we call intermolecular bonds. So it has got the longest chain, and so the greatest molecular atomic molecular mass. So alkene D is got the highest boiling point. So I'll go for alkene E, and the explanation, it has the largest or the longest carbon chain. It has got the longest carbon chain, and this means that it has got the greatest molecular mass. greatest molecular mass, what we call relative molecular mass. Relative molecular mass, MR. Of course, you can see the chain has got how many carbon atoms? 1, 2, 3, 4, 5, 6. So it's the longest carbon chain. So the higher the atomic mass, the stronger the intermolecular force, and therefore the higher the boiling point. Part D, which alkene diffuses more quickly? Explain your answer. Of course, it is ethane because it has the lowest relative molecular mass as the lowest relative molecular mass. Relative molecular mass, MR. So the lighter it is, the faster it will diffuse. Part E. A student added aqueous bromine to ethane C. Added aqueous bromine. Bromine is brown, remember that, in color, and it will decolorize across when it is added to an alkene. Describe the color change and draw the structure of the product. Show all the atoms and all the bonds. The color changes from brown or orange to colorless. So the structure of this one will be how many carbon atoms? 1, 2, 3, 4. So 4 carbon atoms. 1, 2, 3, 4. And then we'll have bromine across here. So we're supposed to show all the atoms and all the bonds. So we have bromine there and another bromine right there. Then we have all these hydrogen atoms. Hydrogen right there. We have hydrogens all here. So that's the color of bromine. Let me call this one orange so that I don't confuse you. All right, so that is the structure. Part F, 2 different alcohols can be produced from alkene B by addition reaction. Draw the structure of the 2 alcohols. This is alkene B. Okay. Show all the atoms and all the bonds. Of course, alkene B, you can have an alcohol here or an alcohol here. So I'll go for the first one. You'll have this. Show all. This is hydrogen there, hydrogen there, hydrogen there, hydrogen there. Of course, to produce an alcohol from alkene, you add steam. So you'll have OH there, and hydrogen, and hydrogen. And since we have to show all the bonds, this OH here becomes H and O. That is 1. Then the other one will add to the second carbon atom here. So you'll have the same number of carbon atoms. Of course, here we'll have our hydrogens right there. But here we'll have our alcohol OH. But here we'll have hydrogen. Then here we'll have hydrogen. Another hydrogen right there. So that is 2 alcohols. This is propanol. This is propanol. And this one is 2, or can call it propan 2O. 2 here indicates that it's bonded to the second carbon atom. The OH is bonded to the second carbon atom right there. Alright, states, and of course these are propanol and propan 2O. These are isomers, you know that. Alright, part 2 states the reagents and conditions needed to produce alcohol from alkene. The reagent is steam, basically water in gaseous state. Then condition is done in high temperature. The temperature should be high enough, of course around 300 degrees Celsius, and catalyst is required. Catalyst under pressure of 60 atmospheric pressure. Those are the conditions required for this reaction. Very good. Part G. Alkene C. Alkene C can be converted into a polymer. Okay. What type of polymerization occurs? We have two polymerization reaction. We have addition and we have condensation. Polymerization. So this is when you have a double bond, is always addition. Polymerization suggests the name of the polymer formed. Of course, you can see the number of carbon atoms in the monomer. This is a monomer. The monomer, the name of this monomer is 1, 2, 3, 4. So but. So this is going to be but 1 in, because the double bond is in the carbon number 1, 2, 3, 4. So you take the list number, so it's 1, but 1 in. So this is going to be poly but 1 in. Remember, when the polymer is ethene, then when the monomer is ethene, then the polymer formed is usually polyethene. So the one in the brackets is the name of the monomer. So that's why this is poly 1 in. Sorry, poly but 1 in. Poly but 1 in. The polymer here is but 1 in. But 1 in. This is 1. Alright, part 3 of this question. Complete the chemical reaction to show this polymerization. Of course, you're going to write the polymer here. Of course, you write this, you break this double bond with a single bond there. Okay. Then, of course, this bond here. And so this carbon atom and these carbon atoms are these ones here. So now here you'll have an hydrogen for this carbon and this other hydrogen here. And then this carbon atom is bonded to this group here. So you write the group CH2, CH3, and then hydrogen. Then you write N there. So N basically means the number of monomers joining up to make this polymer are countless. Can be 1,000,000, can be 1,000, it doesn't matter. So when you're writing the structure of the polymer, you only break the single bond. You only break the double bond to single bond, then write everything else it is. Of course, this is N. Then you write it below here. Okay, state the empirical formula of the polymer formed. The empirical formula is the simplest ratio of the number of molecules present, and therefore you have 4 carbon atoms. So 4 carbon atoms. And how many hydrogen? 1, 2, 3, 5, 8. 8 hydrogen atoms. And therefore, if you write the chemical, the formula is 4C4H8. You can see this is not the simplest ratio, because 8 and 4 can divide by 4. So you get, you divide by 4, you get CH2. So CH2 is the empirical formula, the simplest ratio of the atoms present. So that is the empirical formula right there. Part number 5. Number 5 is from, it was a question on variant 4.2, and this was question number 4. If you need to refer. Methanol is made industrially by reacting carbon monoxide with hydrogen, of course carbon dioxide with by hydrogen, to get methanol. The gases react at a temperature of 250 degrees Celsius and a pressure of high pressure of 75 atmospheres, 75 atm. Of course, the forward reaction we are told is exothermic. The forward reaction, as you can see, the reaction is a reversible reaction. Suggest a source of hydrogen for this process. Suggest a source of hydrogen for this process. There are sources of hydrogen. The common one is hydrolysis of water, acidified water. Hydrolysis of water. Of course, we call it acidified water. We add a little acid, and then, of course, you do electrolysis. And when you do electrolysis, water will break down, and you'll get on one electrode, basically the negative electrode, you'll get hydrogen, and the positive electrode, you'll get oxygen. So you break water into its elements by electrolysis. Okay. Part B of this question. Part B. Complete the table using only words increase, increases, decreases, or no change. Add a catalyst, effect on the rate of the reversible reaction. When we add a catalyst, the rate of a reversible reaction, we are not told either forward or backward, increases. Increases. Of course, in a reversible reaction, as the product form, the reactants also form, because the reaction is reversible, but the rate does increase when you add a catalyst. What about increasing the temperature? We are told that increasing the temperature affects the rate of the reversible reaction by increasing, of course, since the forward reaction is exothermic, we are told the forward reaction is exothermic. Of course, the equilibrium will shift to the left, but that's notwithstanding, increasing temperature increases the rate of reaction, right? What about effect on the equilibrium yield when you increase the temperature for an exothermic reaction? Of course, the yield at equilibrium of methanol will decreases. Remember, the forward reaction is exothermic, so at a higher temperature, the equilibrium position shifts to the left, and that means that less of methanol will be formed. So methanol at equilibrium will decrease. What about decreasing pressure? Of course, the effect of reaction, when you decrease pressure, the rate of reaction decreases. The rate of reaction decreases. What about the yield? at equilibrium? Of course, to answer this, at decreased pressure, that is, to answer this, you need to check. Check the equation, and the equation for production of methanol is this one. You're told when carbon monoxide reacts with hydrogen gas, reversible reaction, we get methanol. Which is also a gas. So all these both reactants and products are gas. So when you decrease pressure, of course, you can see on the left-hand side we have 3 moles, 1 molecule of carbon dioxide and 2 moles of hydrogen, and we have only 1 mole on the right-hand side. So at low pressure, we'll have less of this forming. You understand that according to Lechauret's principle, high pressure will shift this equilibrium position to the side which have less number of moles, and therefore at high pressure the reaction will shift towards more production of methanol at high pressure. But now when you decrease pressure, then the equilibrium position will shift in the opposite direction. More of the methanol will break down to get carbon dioxide and hydrogen, and therefore the effect of methanol decreases. Very well. Part C. Methanol is a member of homologous series of alcohols. State 2 general characteristics of a homologous series. Characteristics. Since they have the same functional group, then they have got similar chemical properties. Like alcohols or acids, they will react the same way. Similar chemical properties. And another, we are told to give 2 general characteristics. We are not actually giving characteristics of alcohol or homologous series. Alcohols, carboxylic acid, alkene, methane, esters, and so on and so forth. So they have similar chemical properties, of course, because they have got same functional group. They have the same functional group. That is why they have similar chemical properties. The second one is that they have got same general formula. Second characteristics they have same general formula. E.g., for ethene, the general formula is, it's that for all ethanes, whichever ethane it is. I'll give you another general characteristic. They have the same functional group. Same functional group. Very well. Part 2. Draw the structure of 2 different alcohols, each containing 3 carbon atoms. Show all the atoms and all the bonds. Of course, what will be, and also name the alcohols. Name the alcohols with 3 carbon atoms. Because I'll go for the first one, which is the simplest one, which has got 3 carbon atoms. 1, 2, 3. Then I will attach the OH there. Then I will satisfy each one of these carbon with the correct number of hydrogens. We give it the hydrogen there. So the name of this one is propanol. We can call it propan 1-ol. Propan 1-ol, meaning that the OH is attached to carbon number 1. Then we can attach the OH to carbon number 2. Then it becomes propan 2-ol. Attach the OH. to carbon number 2. Then we satisfy all the other carbons with 4 bonds, and each one of that is bonded to hydrogen, as you can see right there. It's bonded to hydrogen. So then this is propan for 3 carbon atoms. Propan 2 O. The OH is bonded to carbon number 2. So that's how and I've said that these are isomers. Isomers have got the same chemical formula but different structural formula. The chemical formula for this one is C3H H, let's say 1, 2, 3, 4, 5, 6, 7. H7 or H. Same for this one is C3 H7 or H. They've got the same chemical formula. Okay, but structurally they are different. This one, the OH is bonded to carbon number 1. You name the carbon number 1 carbons this way. This carbon number 1. But this one is the OH is bonded to carbon number 2. You can name 1, 2, 3. So they have the same chemical formula or molecular formula, but they've got different structures, and therefore that makes them to be isomers. Part 3 of C. What term is used to describe compounds with the same molecular formula but different structural formula? Okay, this is what I've just been telling you up there. This is what we call structural formulas, structural isomers. That's wrong with this one. Structural isomers. Okay. Part D. Alcohols will react with the carboxylic acid to produce esters. The structure of an ester is shown here. Name this ester. To name the ester, you first name the alcohol part. This is the alcohol part of the ester. And then this is the acid part of the ester. The acid part. So you usually name first the alcohol, then you name the acid part. So the alcohol part has got 2 carbon atoms, and therefore this is usually ethanol. This part is from ethanol. So we will call this one ethyl. Alright, ethyl. So we write it here. Ethyl, and then you can see the acid has got only 1 carbon, and therefore this acid is methanoic acid. Alright, methanoic acid, and therefore then we call it ethyl methanoate. You change the last 2 words here to "-ate" to imply ester. Alright, so ethyl methanoate is the name of this compound, is the name of that ester there. Part 2. Give the name of the carboxylic acid and alcohol reacted together to this is straightforward. We already done that. So this is a methanoic. The acid is a methanoic acid, and the alcohol is ethanol. Okay. Ester Y is different from ester X, but also has the same formula. Okay, so these are isomers. Draw the structure of ester Y. Show all the atoms and all the bonds. Of course, I will now give this one to be the acid here will be ethanoic acid, and the alcohol will be methanol. Okay, so I'll give this one to be that and that. although we are not taught to name this ester. Of course, you can see it has got 3 carbon atoms, and it has got 6 hydrogen atoms, 1, 2, 3, 4, 5, 6, and it has only 1 oxygen. So it's the same formula. It has actually 2 oxygen there. The same formula as this one. Okay. Now, if I were to name this is the alcohol part. So the alcohol part is from methanol. Okay. This is the acid part, and the acid part is ethanoic acid. So if I were to name this ester, then this ester will be methyl ethanoate. I hope that is clear to every one of us. Though we are not taught to name it, we're only supposed to draw. Question number 6. Question number 6 was from variant 4.3, and this was number 6. 2 hydrocarbons have the structures shown. Hydrocarbon A, hydrocarbon B. This is a cyclic hydrocarbon. This is aliphatic, of course, with a double bond there. It makes it an alkene. Why are these 2 compounds hydrocarbons? They only contain carbon and hydrogen atoms. That is why they are hydrocarbon. They only contain carbon. They only contain carbon and hydrogen atoms. That's why they are hydrocarbons. Okay. Part 2. Hydrocarbon B reacts with, let me just bring it up. Hydrocarbon B reacts in the same way as a typical alkene. Describe a chemical test to tell the difference between hydrocarbon A and hydrocarbon B. State the name of the reagent you will use and the results you will obtain with hydrocarbon A and hydrocarbon B. Okay, and there we are. Also, the reagent we will use here to differentiate between an alkane. This is an alkene, and this is an alkane. We are told that it is bromine water or aqueous bromine water, which is orange. Okay, results with hydrocarbon A, orange color remains. Orange color, for A is an alkene, so orange color becomes colorless. Then for hydrocarbon B, stays orange, no change, because alkanes will not react with the bromine. So the orange color of bromine water is the same. Part B, alkene reacts with steam to form alcohol. Alkenes react with steam to form alcohol. Compound C is an alcohol, because you can see it has got an OH here, which is the functional group of alcohols. Draw the structure of the alkene which could be reacted with steam to make compound C. Show all the atoms and all the bonds. Of course, if it is reacted with steam to make alcohol, steam is 2 atoms of hydrogen and 1 oxygen atom. So if you remove this from this, if you remove that, then you remain with Of course, this is 2 hydrogen atoms and oxygen. So this is now our steam, which we have added to alkene because this is an addition reaction. So then what will remain with is the alkene. So you'll have to, since the OH has been added to this carbon atom, it means that the double bond was between carbon number 1 and carbon number 2, counting from this end. So that's what we draw. We draw that. Of course, the double bond is right there. And if there's a double bond there, we have hydrogen there, and then the rest are also hydrogen to satisfy valency 4 for every carbon. Carbon atoms form 4 bonds. So hydrogen there, hydrogen. So that is the alkene. And if you are to name this alkene, it will just to draw and show all the bonds. And if you are to name this alkene, it will be 1, 2, 3, 4. This will be butene. But of course, you have to specify in which carbon atom is the double bond, because the double bond can be between this carbon atom or this carbon atom here. So this one becomes but 1 in. This is 1. But 1 in. And there you are. Part C. Alkenes can form polymers. Okay, alkenes can undergo polymerization. And what type of polymerization occurs when alkene form polymers? Of course, there are 2 types of polymerization: addition polymerization and condensation. And alkenes undergo addition polymerization. All right. Part 2. Part of the structure of a polymer is shown. You have this polymer here. Draw the structure of the alkene. Draw the structure of the alkene from which the polymer can be made. Show all the atoms and all the bonds. Okay, so you identify to show the structure of the alkene from which the polymer is being made. Basically, what you're being told is to draw the monomer. To draw the monomer of the alkene, which has undergone polymerization to produce this polymer. Okay, so you identify the polymer by looking at the repeat units. So I can see that there is the same as this other unit here, and it's also the same as this other unit here. Okay, so that is the repeat unit, so that should be the monomer. And since it's an alkene, you should introduce a double bond, and you can see the double bond is between these 2 carbons here. So you draw it exactly the same way, but you have to show all the double bonds, and you have to show all the bonds. So I can draw this way. I don't want to change it so that you may just follow. Then there's this double bond, this bond here, bonded to this carbon atom here, which this carbon atom, and this carbon atom is also bonded to an hydrogen. This carbon atom is bonded to this carbon, and therefore that is where the double bond is going to be. We have the double bond there. Then, of course, this will be bonded to hydrogen. Then this carbon atom is bonded to an OH. Let me put this hydrogen up here. Then there's this OH. So I can bring this one here and then give it the 3 hydrogen. Just like that. You can also draw this one in a straight line. So you can stretch it straight. So you can draw 4 carbon atoms. 4 carbon atoms there with a double bond between those 2 carbon atoms. Then you give it all the hydrogen atoms. Hydrogen, just like this. It is the same structure, but now it is drawn in a straight line. It's the same structure as this one. So I hope that is clear. I've done my best to draw that. Part 3. Polymers can undergo incomplete combustion to form carbon monoxide. Of course, incomplete combustion occurs when there is less oxygen. Complete the chemical equation for the incomplete combustion of polythene. The only carbon-containing product is carbon monoxide. So we write carbon monoxide here. All right. But how many carbon monoxide we have? We have N times 2 carbon atoms. So we'll have 2N right there. Then how many oxygen do we have? When we write 2N there, then this becomes 2 oxygen plus 2 oxygen. We have actually we have 2N oxygen, and then here we also have 2N oxygen. So this is 4N oxygen. Okay, but we have 2 oxygen here, so we only multiply this one by 2. So 2 times 2N then becomes 4N oxygen. So there we are, and the equation is now balanced. Okay. Part D. Part of the structure of a polyamide is shown. Okay. This polyamide is formed from identical monomers. Complete the diagram to show the structure of one monomer. Show all the atoms and all the bonds. Of course, this is how we show a block. When you draw a block here, we are meaning that those are number of carbon atoms. Those are a part of the monomer that does not take part in the chemical reaction, and therefore you can see here on the left hand side we have carbon carbonyl compound, carbon bonded to an oxygen through a double bond. Therefore that is what we draw here, carbon here bonded to a double bond, and this monomer should be an alcohol. That's where we get one end should be an alcohol, should be an acidic end, and an acidic end is that. Then the other side should be an amine end. Amine end is nitrogen bonded to 2 hydrogen atoms. This is acid end. An amine has got an acid end and what we call an amine end. So an acid end is this one, and amine end is this one. This is called amide. So when you polymerize this, then you come up with what we call a polyamide. Polyamide. Okay. So this is one monomer up to there. Then the second monomer is this one. And then the last monomer is this one for this polyamide. So this one has got 3 monomers. So we have drawn one of the monomer. I'll show you all the bonds, as you can see right there. Number 7. This equation is about alkenes and petroleum fractions. The table gives some information about alkenes: methane, ethane, propane, butane. Number of carbon atoms increases down. Melting point, you can see the melting point also increases downwards. This is a low melting point. This is a high melting point, close to 0. The boiling point also increases as the number of carbon atoms increases. That is what will be how we are shown there. So answer these questions using only information from the table. Okay, that is key. Describe how the boiling point of alkenes, boiling points of alkenes vary with the number of carbon atoms in each molecule. What are you noticing? The boiling point increases as the number of carbon atoms increases. So just write that. The boiling point increases with, or let me put it this way, as the number of carbon atoms increases. Okay. Which alkane has the lowest melting point? Of course, lowest melting point is 190. A melting point, this is lower than either of these, so that happens to be propane. So propane has the lowest melting point. Deduce, we bring it here, deduce the physical state of butane at 150 minus degrees Celsius, and you have to explain. So butane, this is butane here. Butane has a melting point of this, so and a boiling point of this. So minus 50 is between these two, between 0 and this. So at minus 50, since it has melted at minus 135, so the temperature is increased from 1 minus 35, from minus 135, 134, minus 10, minus 50, minus 10, then to 0. So at minus 50, butane is a liquid. Butane is a liquid. At minus 50. Explanation is that at minus 50, at minus 50 degrees Celsius, okay, let me put it this way. Minus 50 degrees Celsius is between minus 50 degrees Celsius. This temperature is between the melting point and the boiling point. So in between there, it should be a liquid. Part B, part 1, complete the dot cross diagram to show the electron arrangement in a molecule of methane. Show outer shell electrons only. So, of course, this is electron from hydrogen, electron from hydrogen, and not is electron from carbon. So there we go. Just that. Part 2, complete the equation. Complete the equation for the complete combustion of methane. Okay, methane burning in oxygen will give us carbon. Complete combustion will give us carbon. Complete combustion, carbon dioxide. Carbon dioxide and water. This is the word equation. Of course, if you are to write a chemical equation, it would be methane. If you are to write a chemical equation, it would be methane plus oxygen, giving us carbon dioxide and water. Of course, you can balance this. I hope it's balanced. 4 high oxygen, 2 oxygen plus this 4 oxygen. So 2 there. Complete the sentence about homologous series using words from the list: acidic, alkanes, alcohol, carbohydrates, chemical, functional, hydrocarbons, and the physical. Methane and ethane are hydrocarbons. I'll go for hydrocarbons. Methane and ethane, there is no alkene, so they are only hydrocarbons. Hydrocarbons which belong to the same homologous series. Members of alkane homologous series have similar chemical. Okay. similar chemical properties due to the presence of the same functional group. Correct. Part D. Petroleum is separated into useful fractions by fractional distillation. Match the fractions on the left with their uses on the right. So the first one has been done for you. Refinery gas is used for cooking, in what we call cookie gas. It's bottled gas for heating. Bitumen is used for murky roads. So you join up this with murky roads. Kerosene is used as a fuel for aircrafts. And lastly, naphtha is the backbone of many chemicals, so it's used for making chemicals. Okay. Question number 8. This question is about ethanoic acid. Ethanoic acid is given there. Ethanoic acid is manufactured from methanol and carbon monoxide. The equation is given right there. You can see the equation is a reversible reaction. The equation is reversible. The process is done at 200 degrees Celsius and a temperature of 200 degrees Celsius and a pressure of 30 atm. The forward reaction is exothermic, we are told. Complete the table using only words increases, decreases, no change. Adding a catalyst will always increase the rate of reaction. Increases. Of course, catalysts do not affect the equilibrium position or equilibrium yield because they increase both the forward and the backward reaction. Increase the temperature. The forward reaction is exothermic. So when we increase temperature, the yield will decreases. But what happens to the rate of reaction? The rate of reaction at higher temperature will be I, increases. Because one has been done for us. When we decrease the pressure, of course, the rate of reaction, forward reaction will decrease. Now, at high pressure, what will happen to the equilibrium yield? To know that, you get to know the number of moles on the left-hand side. We have one there for methanol and one for carbon monoxide. So on the left-hand side, we have 2 moles. On the right-hand side, we also have 1. We only have 1. So when we increase the temperature, this will shift the equilibrium position towards the right. But what will happen if we decrease the temperature? This will make the yield be converted back to the reactants. So this will decreases. So at low pressure, the yield of ethanoic acid will decrease because the backward reaction will be favored at a low pressure. But at higher pressure, because the number of the number of moles on the reactant side are more than the number of moles on the product side, at higher pressure, the forward reaction will be favored. But at low pressure, the backward reaction will be predominant. B. How would you show that aqueous solution of ethanoic acid is an acid without using an indicator or measuring the pH? State the reagent you'd use and give the expected observation. Write a chemical equation. When you're taught to write a chemical equation, the equation should be balanced. So the reagents I will use is the typical reaction of acids. So all acids react with carbonates to give carbon dioxide. So let me just choose one carbonate here, magnesium carbonate. That is a reagent. What is the expected results? I will see bubbles of a gas, which is carbon dioxide, will form. And a chemical reaction here, excuse me, the magnesium carbonate, which is a solid, will react with ethanoic acid, which is aqueous, and what you'll get is a salt of magnesium, which we call magnesium ethanoate. Magnesium ethanoate. This has got a valency of 1. That's why you need to put in bracket to multiply by 2 there. Of course, this is soluble. Then carbon dioxide, which is a gas, and some water, which will be liquid. So there we are. That's the chemical reaction. Okay. Lastly, part C. Ethanoic acid is a weak acid. What does the weak acid mean? What is meant by a weak acid? This is an acid which, what is the term acid? An acid is a proton donor. Okay. An acid is a proton donor. What is a proton? If you consider the atom of hydrogen atom has got only 1 electron. Therefore, if you remove the electron, what are you remaining? It's 1 electron and 1 proton. So if you remove an electron from hydrogen, of course, what you remain with is a positively charged hydrogen plus an electron. This is what we refer to as a proton. So when it donates an hydrogen ion, then it is donating a proton. So we call an acid is a proton donor. Like for example, hydrochloric acid. When it undergoes dissociation, it forms hydrogen ion plus chloride ion. This is a proton. So it will donate an hydrogen ion, and therefore we call that a proton. Why is ethanoic acid described as a weak acid? It undergoes partial dissociation. So you can say dissociates partially. Dissociates partially. Partial dissociation. What does that mean? Ethanoic acid will undergo a reversible reaction, and it will get us an ethanoate ion and an hydrogen ion. But once these two form, they will also combine to form back the ethanoic acid. Therefore, it is partial dissociation. Unlike HCl here, you can see the reaction is one-sided. It will dissociate fully. The ions will not combine again to get back the molecule of hydrogen chloride or hydrochloric molecule, hydrogen chloride molecule. Lastly, part D. Ethanoic acid reacts with methanol to form an ester. Ester is a sweet-smelling compound. State 2 conditions required for this reaction. You need to heat, and there should be a catalyst. This reaction takes place in acidic medium, so the catalyst is usually an acid, which is sulfuric acid. Then draw the structure of the ester formed. Draw the structure of ester formed when ethanoic acid reacts with methanol. Show all the atoms and all the bonds, and lastly name the ester. So ethanoic acid on the left has got 2 carbons. Okay, give hydrogen here, hydrogen, and then of course it will bond with methanol. Methanol is only 1 carbon atom, and then hydrogen there, hydrogen and hydrogen. And this part of the alcohol is methyl, because it is from methanol, so it is methyl. And this is the part that is from the acid, and it is from this acid, ethanoic acid, and therefore it is the ethanoate. So you combine these two, then the name of this ester will be methyl ethanoate, and this is an ester, a sweet smelly ester. Okay. Part 3. Name, of course, an ester which is a structural isomer of the ester in D part 2. Of course, in this case, you just interchange the acid and the bases, the acid and the alcohol. So the acid here becomes methanoic acid. Methanoic acid. The acid was ethanoic acid initially, so you just change it to methanoic acid, and the alcohol becomes now ethanol. If you are to draw this, it will look like this. Hydrogen there. So this. So this is the part that is from the alcohol, which is ethyl, because the alcohol is ethanol. So this is ethyl. What am I writing? Ethyl. And this is the part from the acid, which is methanoate. So the name of the ester will be ethyl methanoate. Ethyl methanoate. Very good. So you earn that 1 mark. Thank you very much for sticking with me up to this point. This is the last question. I hope I've helped you in this organic compound topical question. Hopefully you'll follow me in my soft paper channel to see more of this kind of topical question when I solve and upload. So please subscribe. Cheers and see you